I'm Anil Kumar, and in this video we will learn how to find increasing and decreasing interval for a composite function. Consider the composite function h of x equals to f of x times g of x, where f of x is x squared plus 3x plus 2 and g of x is x minus 1. Determine increasing and decreasing interval for h of x. So basically we know what h of x is. It is equal to product of f of x and g of x. So we could write this as x squared plus 3x plus 2 times g of x, which is x minus 1. Now to find increasing and decreasing interval for a given function, what should we do? We should find its derivative. So derivative of this function is h prime of x. We can apply the product rule. Derivative of the first function is 2x plus 3 times x minus 1 plus derivative of the second function is 1, so 1 time x squared plus 3x plus 2. And now we need to simplify it. Now to simplify it, what we can do is we can just expand and then simplify. So let's multiply by the first terms. So we get 2x squared minus 2x plus 3x minus 3 plus x squared plus 3x plus 2. Combine the like terms. 2x squared plus x squared is 3x squared. Minus 2x plus 3x is x. X plus 3x is 4x. We get 4x here. Constants, minus 3 and plus 2 is minus 1. Now to find increasing and decreasing intervals, we need to find the critical number. So we'll equate h prime x as 0 to find critical numbers. Let me write down here, right? So this is very important step. We will find the critical number. So that is to say, we'll find solution for 0 equals to 3x squared plus 4x minus 1. Now to find this solution, you could actually use quadratic formula. So let's use quadratic formula and find the solution for this given equation. So here so let's use quadratic formula to find solution of this equation, which is 3x squared plus 4x minus 1 equals to 0. The quadratic formula, you remember, is x is equals to minus b, which is minus 4, plus or minus b squared, that means 4 squared. So I'm writing 4 squared minus 4 times a is 3 and c is minus 1, right? So divided by 2 times a, which is 3, right? So that is the quadratic formula. So we can use calculator to find this answer, right? So well, let's simplify it a bit more, so we'll get back to calculator later. So we have minus 4 plus minus square root of 16 minus minus becomes plus. 4 times 3 is 12 over 6, right? So which is 28, and as you know, 28 is not a perfect square, so we'll use the calculator now. So we say square root of 16 plus 12, which is 28, is what? So we'll write decimal equivalent 5.29. So we'll use 5.3 here, right? So we could write this as approximately minus 4 plus minus 5.3 divided by 6, right? So let's find both the values, one with plus and the other one with minus. So let us say 4 plus 5.3 equals to divided by 6, and we know it is negative sign. So one of the x values is equal to minus 1.55. The other value is, when you use plus, you get 1.3 divided by 1.3 divided by 6, which is the other value is 0.2166, right? So that is what we get, right? So let us say these are the two x values for us. So at these two values, the given function is 0, right? Now what we need to find is how does it change on either side of these zeros. So basically what we will do now is analyze the derivative. So we'll analyze the derivative on a number line. Let's say this is a number line. And on this number line we have these two zeros for the derivatives. So the two zeros are at minus 1.55 and the other one is at plus 0.216, right? Okay. Now these 2 points divide the interval into 3 regions, correct? So we'll take points in these 3 regions. So we say test points. So test points could be 0 in this. Greater than that, 0.2 is 1. Less than this could be minus 2. And what we will see is what happens to h prime x at these values. We have to just check the sign, right? Whether it is negative or positive. If I write 0 here, for example, these two terms is 0, we are left with minus 1. So we know in this portion it is negative, right? So here it is negative. On these two sides, if I write 1 here, so if I write 1 here and evaluate h prime. So what I'm trying to say is, so h prime of 0 is negative. And h prime of 1 is, when I write 1, it does get 3 plus 4, 7. 7 minus 1 is positive. I'm not interested in value. And h prime of minus 2, if I substitute minus 2 here, minus 2 square is 4. 4 times 3 is 12. 12 minus 8 is 4 plus, and 4 minus 1 is 3, right? So it's 3, which is positive, right? So on either side of this interval, which is from minus 1.55 to this, it is positive, correct? So positive means slope is kind of rising. Do you see that? But it's negative in this portion and positive here. So that is the nature of the derivative of the function, right? So the derivative is increasing here, decreasing in these points. Is it okay? So that is how the derivative is, if you see from that particular point, right? So what we notice here is that during the interval from these 2 points, the exact values you could write as minus 4 plus minus square root of 28 divided by 6, which we could actually simplify better. So let me write down here xs equals to minus 4 plus square root of 28 as divided by 6, right? So this is the value of x plus minus. So what we notice is that interval of decreasing is within these two roots. So it is decreasing in the interval when the value is between minus 4 minus square root of 28 divided by 6 to minus 4 plus square root of 28 divided by 6, right? Divided by 6, right? So within this interval, it is actually decreasing, right? And on the other intervals, the derivative is increasing. So the function is increasing in the other one. So decreasing in this interval, and let me write down increasing here. Increasing in the interval from minus infinity to this number, which is minus 4 minus square root 28. So that becomes the exact answer, right? So that's the whole idea. And so we say union minus 4 plus square root 28 over 6 to infinity. You get the idea. So that is the place where it is increasing, right? At times what you can do also, this is a quadratic function, h of x, so you could just sketch the function here, right? So you can say these are my two zeros, so the quadratic function is a parabola which is opening upwards. Since these two are zeros, I know this portion is negative, those two are positive, right? So I do not have to do all these calculations. It's very clear from here that the derivative is positive from minus infinity to the first root and is positive from the second root to plus infinity. So those are the intervals where the function is positive, right? So, or is increasing, I should say, increasing. And in between, the function is decreasing since the tangent or slope at any point in this interval is negative. So it is decreasing in this portion. I hope you understand the concept, and that is how we should be solving such questions. Thank you and all the best.